Hello everyone. Today we're going to talk about effortless demand prediction with Google BigQuery ML. I'd like to start with a quote from John Nesbitt. He said, "The most reliable way to forecast the future is to try to understand the present." And that's what we're going to do today. My name is Anitya Paramasari. I'm a data scientist at Dagangan. I'm also an ML engineer at Omdina and member of AI Wonder Girls. In addition to a master's degree from the University of Edinburgh, I also have certifications in data science, machine learning engineering, and cloud computing. So, do you perform demand forecasting at work? Most companies need demand forecasts for their products or services. So, I find it tedious to move and transform data before analysis sometimes. And today we're going to look at a solution for that from Google BigQuery ML. Demand forecast is a type of time series analysis. But what is a time series analysis? It is a specific way of analyzing a sequence of data points collected over an interval of time. Here we are trying to understand the underlying causes of trends or systemic patterns over time. We're also going to predict the likelihood of future events, or what is called forecasting. And we're going to use Google BigQuery. But why do you use Google BigQuery? So BigQuery itself is a serverless, cost-effective, multi-cloud, fully managed enterprise data warehouse designed to help you turn big data into valuable business insights. They have built-in features including machine learning, geospatial analysis, and business intelligence. A feature that we're going to use today, which is BigQuery ML, is used to train and access machine learning models and or perform predictive analytics, including time series analysis. Why use BigQuery ML? When we use BigQuery ML and your company already has its data in Google BigQuery, we don't need to move data. It's pretty simple and easy. It makes it a breeze to analyze your data here, there, and there. And it also automatically handles anomalies, seasonality, and holidays. Amazingly, it can also forecast up to 100 million time series simultaneously with a single query. I think that's amazing. And it's also accessible through different methods. So if you have your preferred methods, you'll be able to use it. So how do we access it? These are the methods we can use to access BigQuery ML. Of course, we can use the Google Cloud Console, which is the simplest way to do it, the GUI. And we can also use the BQ command line tool. If you're more familiar with the command line CLI, and we can also use the BigQuery REST API if you want, especially if you want to combine it with other apps. And there's also external tools that you can use, such as Jupyter Notebook or Business Intelligence platform. So here is the schema of how BigQuery ML does time series analysis. I'm not going to go deep into the details, but here we can see the input time series, and then it does the pre-processing, and then it goes to modeling, and after all these are taken into account: holiday, outlier, season, step change, and residual. They become decomposed time series, and they will be aggregated into the forecasted time series and interval. There will also be the seasonal trend, holiday, outlier, and step change components taken from the data. Let's talk about the data now. If you have your data, you need to prepare them in this format. The first one is the date column, which is the date of the transaction. The second one is sales quantity, which is the number of products sold on a specific day. And the third column would be the product ID, which is the ID number of a specific product. So if you have your data in a different format, you need to reformat them in this way, most likely using SQL. With this schema, it's going to be very easy for BigQuery ML to create the model. And here comes the code. This is the full syntax. Don't be alarmed. This is just the full syntax that you can use. Of course, we won't be, most of the times we won't be using the full syntax. And now we're going to get into an example of a code. Yeah. The first step is to create or replace model. Yeah. In this case, we're just going to name it demand forecast. And then we're going to add options. Yeah. And at the bottom, don't forget to add as query statement, because overall this is a SQL query. Yeah. For the first option, we're going to type model type. In this case, we're going to use Arima Plus. And then the second part is the time series timestamp column. We have decided earlier to name the timestamp column with date. So we're just going to write it here, date. But if you have it named differently, like transaction date or time of transaction, etc., don't forget, just put it here. Yeah. And then the next one is the time series data column. This is the value that we're going to predict or forecast. Previously, we have decided to call it sales quantity. Of course, you can name it anything, but it's always better to make it simple and understandable. Yeah, easy to understand. And the next one is time series ID column. This is the product ID. It's pretty self-explanatory, and as we discussed, we can have up to 100 million product ID, which is amazing. Yeah, so the data is in a long format. Yeah. The next option is the horizon. So this is how far we're going to predict. Because this is a daily data, we have the sales quantity data based on dates. I decided to just put 7 here, meaning that we're going to predict the demand for 7 days or a week. Of course, if you have longer training data, longer period of training data, you can put more than 7. You can even put 30 for a month if you want to. And then auto arima, I've decided true. This is to decide whether the model in the training process should use auto arima. If true, the training will automatically find the best non-seasonal order, which is the P, D, and Q. We'll talk about it in the next part. So the auto arima max order, this is what you need to decide if you decide to use auto arima. This one decides the maximum value for the sum of non-seasonal P and Q. So P is the autoregressive, which is the number of autoregressive terms, and Q is the moving average, which is the number of lagged forecast errors in the prediction equation. The default value is 5. If you want the training to be shorter, the training time to be shorter, you can change it to a smaller number, for 3 for example, but the accuracy of the forecast won't be as accurate. Yeah. The next one is data frequency, because our data is daily. We just put it daily. Of course, you can change it into weekly or monthly. And the holiday region, to be safe, I've decided to use global. Because I'm in Indonesia, I can decide to use ID, or you can decide to use NA if you don't want to take into account the holiday for your trend. And then include spikes and dips. This is where you decide whether you want the training to take out the outliers. Adjust step changes. This is where you set whether the training model would automatically adjust if there is step changes, if there are step changes in the data, in the training data. Decompose time series. This is where you decide whether the result forecast would include the training data. And then there's the time series length fraction. This is a fraction of the training data which will be used to decide on the trend. If you have training data for longer than a year, for example, you don't need 100% to or 1 to decide on the trend. Of course, the whole data will be used to train on the other components, other than trends. And then the minimum time series length is set to 20. This is to be safe. If the fraction of 0.8 for one time series, for example, a specific product is less than 20, then it will use 20 instead of something less. And then if you want to evaluate the model, we can just use this with the model name, this syntax. In this case, we'll just use the demand forecast as the name of the model. Thank you for watching. In the next session, I will give you a hands-on demo on this. Thank you.